Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from March 2023, paper 2, variant 2. In this lesson, as always we do, we will discuss these questions in detail so you can improve your conceptual understanding of this topic and also you can have better understanding of these questions. Let's study together, let's improve together. In today's class, we are talking about March 2023, paper 2, variant 2, and total time for this exam is 1 hour and 15 minutes. And total mark for this paper is 60. On second page of exam paper, some important data is given to you. Means values of some important constants are given. If you need value of any constant in your exam, you can come to this page and you can find values of constants. On second page of exam paper, you can also find some important formulae, but these are not all the formulae you need for AS physics. So in the exam, if you have forgotten any formula or you just want to double check, you can come to second page and you can find some basic and important formula. For question number 1, part A, we need to underline all the SI base units in the following list. Ampere. Ampere is SI base unit of current, so we can underline this one. Coulomb. This is SI unit of charge, but this is not SI base unit, so simply we can leave this. Current. This is SI base quantity, but this is not SI base unit. Kelvin, this is SI base unit of temperature, so we can underline this one. Newton, this is SI unit of force because this is part of SI system, but this is not SI base unit, so simply we can also leave this one. So in this case, if you have underlined ampere and Kelvin, you will get 1 mark, and that is B mark. If you go to part B, for part B, it is given to us a car moves in a horizontal straight line. The displacement S of the car is given by this equation, where A is the acceleration of the car and V is its final velocity. We need to state 2 conditions that apply to the motion of the car in order for the above equation to be valid. Means when we can use this equation for the motion of the car. So for the car, we need to understand it is given to us the car is moving in a horizontal straight line. So the car is moving this way. Just imagine it is moving to the right. Then it is moving in a horizontal straight line. If you look at this equation carefully, we can simply figure out that this is coming from V square minus U square, that is equal to 2AS from kinematic equations, or simply we can say from SWOT equations. We have 5 equations, so this is one of them. Now in this case, if we compare these two, simply we can find out if U is equal to 0, then simply we can say V square will be equal to 2AS, and then we can make S the subject and we can write down this is equal to V squared divided by 2A. So one condition for the motion of the car is that initial velocity of the car has to be 0. So we can simply say we can use this equation if initial velocity of the car is 0. So simply you can say if initial velocity of the car is 0, we can use this equation. And the second condition is that we can use this equation only if A is uniform, or simply you can say if A is constant, if A is uniform. So if A is uniform, we can use this equation. When we say acceleration is uniform, we are talking about magnitude of acceleration is constant. So we are talking about magnitude of acceleration, that is constant. Then also we are talking about direction of acceleration, that also has to be constant. Means the car has to move in one direction. So magnitude has to be constant and direction of acceleration also has to be constant. Means same direction all the time. So in this case, car is already moving in a straight horizontal line. So it means that direction is constant. So if we have to use this equation, then magnitude of acceleration also has to be constant. Because question is asking you, state 2 conditions apply to the motion of the car. I mean, what kind of motion car has when we can use this equation? So first one, initial velocity of the car has to be 0. And the second condition is that magnitude of acceleration of the car has to be constant. Magnitude of acceleration of car has to be constant. So simply you can say magnitude of acceleration is constant. Then we can use this equation for the motion of the car. I mean, this equation can describe the motion of the car. Magnitude of acceleration is constant. So you need to understand the whole physics, not just part of that. So if you adopt this kind of habit, always try to write on the complete answer, the right physics, the whole physics. You will develop your understanding of physics in a proper way. So magnitude of acceleration of this car, if it is constant and initial velocity is 0, then we can use this one. So we have to write on these 2 points. If you have written these 2 points, you will get 2 marks because this has maximum 2 marks. So one B mark for initial velocity 0 and a second B mark if you have written acceleration is constant, or if you have written the proper answer, magnitude of acceleration is constant, so you will get 2 marks. For part C, it is given to us an experiment is performed to determine the acceleration of the car in B. The following measurements are obtained. So value of S we have and value of V we have, and we need to find out value of A in this case. But in the last equation we have seen that S is equal to V squared divided by 2A, and now we need to find out value of A, so we can make A the subject. So A in this case will be equal to V squared divided by 2S, and value of V is given to us, that is equal to 2.75. 2.75 squared divided by 2 times, then value of S is given, that is 3.89. If we solve this one, our final answer will be equal to 0.972, and we have to write on this one up to 2SF, up to 3SF, because the given data has 3SF. So it's better to use 3SF. So our final answer will be 0.972. In the mark scheme they have written 0.97, but the proper way of writing is up to least number of SF in the given data. So as given data has 3SF, so we have to write on this one also up to 3SF. So this is a good practice, but mark scheme is also accepting 0.97 up to 2SF. Now if we go to the second part, for the second part, question is asking us to calculate the percentage uncertainty to 2 significant figures in A. Percentage uncertainty in A. So the percentage uncertainty in A, this one will be equal to percentage uncertainty in S plus percentage uncertainty in V. But in this case, V has a power. The power of V is 2. So we have to multiply this one by 2. And we have to ignore in this case this 2 because 2 is coefficient of S and it's not a scale factor. So it simply means that, for example, if I have X, this is equal to 2S, and we calculate the fractional uncertainty in X. So we will write down delta X by X, and this will be equal to 2 times delta S by 2S. So simply you will get this is delta S by S. So it simply means that 2 will be cancelled because 2 is a coefficient, but it is not a scale factor. So you can simply ignore this 2. Now we need to simply plug in values. We have percentage uncertainty in S, that is equal to 0.5%, 0.5%, plus we have percentage uncertainty in V, that is equal to 0.8%. If we solve this one, our final answer in this case will be equal to 2.1%. We have to write down our final answer up to 2SF. So this is our final answer. So this is how you can write down final answer. For the first question, if you have got the right answer, you will get 1 mark, and this is answer mark. And for the second question, if you have written these steps, you will get 1 mark, and this is C mark. And if you have got the right answer, you will get another mark, that is answer mark. But if your answer is wrong, but you have written these steps, still you'll get 1. For the last part, we need to use our answers from C1 and C2 to determine the absolute uncertainty in the calculated value of A. Absolute uncertainty. In part C1 and C2, we have calculated value of A, and we have also calculated percentage uncertainty in A. Value of A we have calculated, that was equal to 0.972, and we have calculated the percentage uncertainty in A. And percentage percentage uncertainty in A was equal to 2.1%. So percentage uncertainty A, you can also write down, this is delta A by A multiplied by 100. And this is equal to 2.1. We need to calculate delta A in this case. So simply delta A, you can say delta A will be equal to 2.1 divided by 100 multiplied by A. And value of A we have. We can write in 2.1 divided by 100 times value of A. A is equal to 0.972. Now, if we solve this one, our final answer will be equal to 0.02 up to 1 SF. So this has to be up to 1 SF because absolute uncertainty always at AS level, you have to write down up to 1 SF. So our final answer for this question is 0.02. If you have got this answer, you will get 1 mark, and that is answer mark for this question. So this is a proper way how you calculate absolute uncertainty. For our second question, it is given to us a motor uses a wire to raise a block as illustrated in figure 2.1. The base of the block takes a time of 0.49 seconds to move vertically upwards from level X to level Y at a constant speed of 0.64 meters per second. During this time, wire has a strain of 0.0012. The wire is made of metal of Young's modulus 2.2 times 10 to 11 pascals and has a uniform cross section. The block has a weight of 1.4 times 10 to 4 newtons. Assume that weight of the wire is negligible. For part A, we need to calculate the cross-sectional area A of the wire. Now, first thing we need to understand, for this question it is given to us, block is moving at a constant speed. As the block is moving at a constant speed, it simply means that the net force on this block is equal to 0. If we assume force F is acting vertically upwards, this is the force provided by the motor, then we can say the force acting downwards, this force is equal to weight, and weight and F, they have to be equal. So these two forces, they have to be equal in magnitude. So as these two forces are equal, we can also say in this case the tension in this wire, that is also equal to W. So we can also write down here tension is also equal to W, and W is equal to F. We need to calculate cross-sectional area, but in this case we have value of strain, we have value of force, we have Young's modulus. So simply we can use in this case that Young's modulus E, this is equal to stress over strain. So this is how you can relate this data, stress over strain. So simply first step you can write down E is equal to stress over strain, and stress is equal to force over cross-sectional area, and strain, value of strain directly is given to us, so simply we can use symbol for strain. For this question, we need to calculate A. So we can rewrite this one. So we can say Young's modulus in this case is equal to F divided by A times epsilon. And we need to calculate A. So we can make A the subject. So A in this case will be equal to F divided by Young's modulus times strain. Now simply we need to plug in values. In this case we have value of F, that is equal to weight, and that is 1.4 times 10 to 4 divided by Young's modulus. Well, if Young's modulus is given, that is 2.2 times 10 to 11, and value of strain is given, that is 0.0012. Now, if we simply solve this one, in this case our final answer up to 2SF, we have to use 2SF because given data, the least number of SF in given data are equal to 2SF. So our final answer is 5.3 times 10 to minus 5 meter square, because SI base unit of area is meter square, means SI unit of area is meter square. And so we can write down this is 5.3 times 10 to minus 5. And this question has 2 marks. The first mark you will get if you have written E is equal to this one. So we can say you have the C mark for this part. So if you have written this step, you will get 1 C mark. And if you have got the right answer, you will also get another mark, and that is answer mark. So this is how marks will be awarded. For the second part, we need to calculate the increase in the gravitational potential energy of the block for the movement of its base from X to Y. Means when the block moves from X to Y, from here to here, what is the increase in gravitational potential energy of the block? But for this case, it is given to us when the block moves from X to Y, the speed of the block is given to us. Speed of the block is 0.64 meters per second. And the time taken from X to Y is also given. That is equal to 0.49 seconds. And the block is moving at a constant speed. So in this case, we can calculate the distance between X and Y. So we can simply write down delta at XY is equal to the speed, means V times T. And so we can calculate first of all the change in height. So that will be equal to 0.64 times 0.49. So this is how we can calculate the change in height in this case. But we need to calculate the increase in gravitational potential energy, means delta GPE, the change in gravitational potential energy. And change in gravitational potential energy will be equal to mg times delta H. And mg is the weight of the block. And weight of the block we have here. So simply we can plug in these values. Weight of the block is equal to 1.4 times 10 to 4 times we have the change in height delta H, that is equal to 0.64 times 0.49. Now if we simply solve this one, our final answer in this case will be equal to 4390.4. So this is up to 5 SF. But if you look at given data, this is given up to 2 SF. So simply we can write down our final answer. This is 4400 up to 2 SF. So this is our final answer. And this is how you can figure out this type of questions. And this question has 3 marks. The first mark is if you have calculated the value of delta H, you will get 1 mark. This is C mark. And the second C mark is if you are using this formula, you will get another C mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks. But if your answer is wrong, but you have written these steps, still you will get 2 marks. For part B, it is given to us the motor has an efficiency of 56%. And we need to calculate the input power to the motor as the base of the block moves from X to Y. Means when this block moves from X to Y, we need to calculate input power to the motor. So simply first of all, we can imagine in this case, this one is the motor. So simply you can imagine this one is the motor. And motor has input power. So you can also draw this arrow. So this arrow is representing input power. So this is the input power. And also we can draw an arrow here. So this arrow is representing output power. So this is output power. And efficiency of this motor is given to us. Efficiency of this motor is equal to 56%. So this is efficiency of this motor. Now we can write down efficiency. Efficiency will be equal to P output, means the P out divided by P in, means the input power. And we need to calculate in this case P in. So P in simply is equal to P out divided by the efficiency of the motor. And P out in this case, simply we can calculate the force applied by the motor, means the tension in this wire. And this block is moving at a constant speed. We have already discussed this point. So the force acting downwards is equal to the weight of the block, and the force provided by the motor, means the tension in this wire, that will be equal to weight. And the value of weight is given, that is equal to 1.4 times 10 to 4. And the speed of this one is given to us. The block is moving upwards with a constant speed, that is equal to 0.64 meters per second. So simply we can say the power output is equal to F times V divided by the efficiency of the motor. And so force in this case is equal to 1.4 times 10 to 4. And this is the force provided by the motor. And that is equal to tension in the wire. And the speed we have, that is equal to 0.64. And we need to divide by efficiency. That is 0.56. Now if we solve this one, our final answer in this case will be equal to 1.6 times 10 to 4 watts. So this one is the input power, and here we have the output power. Output power is equal to this one. So this is how we need to figure out. If you have written these steps, you will get 3 marks. The first mark you will get if you have written this one. You have written P out is equal to FV, you will get 1 mark. So this is 1 C mark. And the second mark you will get if you have written this whole, mean if you have written this formula and you have plug in these values, you will get the second mark, and that is second C mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks for this question. For part C, it is given to us the base of the block now has a uniform deceleration of magnitude 1.3 meters per second from level Y until the base of the block stops at level C. We need to calculate the tension in the wire as the base of the block moves from Y to C. So simply, first of all, we can draw a tiny block here. So this is the block at this point. Then the block finally stops at level C. Now we need to understand when the block is moving from Y to Z, in this case the force acting on the block upwards, that is equal to tension, and the force acting on the block downwards, that is equal to weight, and this block is decelerating. So it simply means that acceleration is in opposite direction of velocity. So simply we can say acceleration is downwards, and the value of acceleration is given, that is equal to 1.3 meters per second. And for this question we need to find out value of t. As block is decelerating and acceleration is downwards, it means the downward force is greater. So simply we can start from here. We can say in this case F net is equal to ma, and in this case, W is greater than T because block is decelerating, or simply you can say block is accelerating downwards. So we can say W minus T, this one will be equal to MA. So we need to calculate, in this case, tension in the wire. We need to calculate T. So simply we can say T in this case will be equal to W minus MA. W minus MA. So we move T to the right and we move this one to the left. So W minus MA, this is equal to T, and we need to calculate value of T. W we have, that is equal to 1.4 times 10 to 4. So this is the way, minus M. We need to calculate mass of the block. So mass of the block will be equal to weight 1.4 times 10 to 4 divided by 9.81 multiplied by acceleration. Acceleration we have, that is equal to 1.3. So if we solve this one, we will get our final answer, that will be equal to 1.2 times 10 to 4. And this answer is smaller than W. It means answer is right. 1.2 times 10 to 4 newtons. If you got answer bigger than weight, it means there is something wrong with your calculations. So this is value of T. So this is how you can calculate, and final answer has 2SF because given data also has 2SF. So we can use 2SF in our final answer. So you can simply write down 1.2 times 10 to 4 Newton. So this is the answer. And this question has 3 marks. You will get first mark if you have written this one. So you will get 1 C mark. And the second mark you will get if you have written this second step. You will get the second C mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks. For the last part on figure 2.2, we need to sketch a graph to show the variation with time t of the distance d of the base of the block from level x. Numerical values of d and t are not required. So in order to answer this question, we need to understand the motion of the block between x to y and y to z. We have already discussed that between x and y, block has constant speed. So simply we can write down block has constant speed, or you can say constant velocity, because block is just moving in straight line, meaning just moving upwards. And between y and z, block has constant deceleration, means the velocity is decreasing at constant rate, constant deceleration, and block finally stops at z. So we can say at z, speed of the block is equal to 0, means block just stops at z. Now we also need to understand that gradient of dt graph, this is equal to speed. gradient dt graph is equal to speed. Now we have also discussed that block has two different kinds of motions. So simply we can divide this one into two parts. Between x and y, block has constant speed, and between y and z, block has constant deceleration. Between x and y, block has constant speed. It means the gradient of the graph has to be constant. It has to be a straight line. So simply we can draw the straight line between x and y. Because speed is constant, it means the gradient of line also has to be constant. So this is how you can draw between x and y. And between y and z, block has constant deceleration. It means that the speed of the block is decreasing. So gradient of the graph has to decrease. So simply you can draw like this with decreasing gradient. And finally at z, this has to be horizontal because block stops. So this part has to be about horizontal at z. So this is how you can draw the graph. If you sketch like this, you will get the marks for this graph. Simply we can draw in a proper way. Otherwise, we can redraw the second part. So if you draw like this is acceptable. So this is horizontal, it means its speed is 0. So horizontal is telling us gradient 0, it means speed 0. So if you draw this curve like this, you will get in this case 2 marks because this question has only 2 marks. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from March 2023, paper 2, variant 2. In this lesson, as always we do, we will discuss these questions in detail so you can improve your conceptual understanding of this topic and also you can have better understanding of these questions. In the last video, we have already discussed question 1 and question 2. And for the solution of those questions, you can go to the channel and you can check for part 01. Let's study together. Let's improve together. For part A, we need to state two conditions for an object to be in equilibrium. Condition 1 is sum of all the forces in any direction has to be equal to 0. So we can say sum of all the forces in any direction has to be equal to 0. Or simply you can say resultant force in any direction has to be equal to 0. So this is the first condition. And the second condition is net moment has to be equal to 0 about any point. Net moment is equal to 0 about any point. Now simply you can say clockwise moment has to be equal to counterclockwise moment about any point. So we can say about any point. I mean if you choose any point and you take the net moment about that point, clockwise moment means the sum of clockwise moments has to be equal to sum of counterclockwise moments. So we can say about any point. So it's very important to understand the full concept. Not only if you remember net force is equal to 0, net moment is equal to 0, that is not complete answer. So you need to remember resultant force in any direction has to be 0, net moment about any point has to be 0. So for the answer of this question, simply we can say resultant force in any direction is 0, or you can say is equal to 0. In any direction is 0. So this one is the first condition. And the second condition is net moment about any point. Net moment about any point is 0. About any point is 0. So if you write down these two conditions, you will get 2 marks. And these are 2 B marks. I mean, if you write down the first one, you will get 1 B mark, and if you have written the second one, you will get another B mark. For part B, we need to show that the vertical component of the tension in the string is 13 newtons. And you can see value of tension is given to us, that is equal to 17 newtons in this case, and we need to find out its vertical component. So this is the horizontal component, and this one is the vertical component. Question is asking us to calculate vertical component of tension. So we can say this one is TV, and TV in this case will be equal to T sine of 50 degrees. So simply in this case, we need to write down TV means the vertical component of tension. This is equal to T sine of 50 degrees. And now simply you need to plug in values. We have 17 sine of 50 degrees. If we solve this one, our answer up to 2SF will be equal to 13 newtons. So this is value of TV. And this question has only 1 mark. If you have got the right answer, you will get 1 answer mark. For part C, question says by taking moments about and A, calculate weight W of the beam. So we need to calculate weight W of the beam and we need to take moments about this end. So in this case, first of all, we have already discussed that tension has 2 components. One is the vertical component of tension. So this is the vertical component of tension and this one is horizontal component of tension. So we have already calculated vertical component of tension TV that was equal to 13 newtons. So now we need to take moments and we need to calculate value of W. So if we take moment about this point, so the moment due to weight, this one will be clockwise, and moment due to this weight also clockwise, and moment due to vertical component of tension, this one will be counterclockwise direction, but due to horizontal component, moment will be equal to 0 because line of action of force is just passing through the pivot point. So there is no perpendicular distance. So the moment due to this one will be equal to 0. Now simply we need to equate as this beam is in equilibrium. So we can say sum of clockwise moments. So first of all, we can write down clockwise moments has to be equal to sum of counterclockwise moments. In this case, we have clockwise moment due to W. So we can write down W times. And the length of this beam is 0.5. So it means the distance from the weight to this beam, that one will be equal to 0.25. So we can say this one will be equal to 0.25 meters. So simply we can multiply this one with 0.25 meters. Plus moment due to this one is also clockwise and the force is 12 newtons and the distance from the pivot, perpendicular distance, that is equal to 0.35, and this one has to be equal to moment due to vertical component of tension times the distance from the pivot, perpendicular distance, and that distance is equal to 0.50. Now if we solve this one for W, we can find out value of W, and in this case value of W will be equal to 9.2 newtons. So this is our final answer. And this question has only 2 marks. The first mark is the C mark. If you have calculated values of the moment, you will get 1 C mark. And if you have got the right answer, you will also get answer mark. So this is how marks will be awarded to you. For part D, we need to calculate the magnitude of the vertical component of the force exerted on the beam by the hinge. Exerted on the beam by the hinge means the force on the beam at this point. And this force is by hinge. So we need to calculate vertical component of this force. So simply first of all, we can draw the arrow. So this force we need to find out. But in this question, we have also already discussed that there is a vertical component of tension that is acting vertically upwards. So this is vertical component of tension. Now in this case, as this beam is in equilibrium, so it means that sum of the forces along vertical has to be equal to 0. So in this case we have 4 forces now. So we can say this force is F, let's say this force is F, and we can say this force is the hinge force, FH we can say, and this force we need to find out. In this case we have vertical component of tension that is equal to 13 newtons, and we have weight that is equal to 9.2 newtons. These 2 forces are acting vertically downwards and these 2 forces are acting vertically upwards. So the sum of upward forces has to be equal to sum of downwards forces. So simply in this case we can say 9.2 means the weight plus 12 newtons. This one has to be equal to 13 plus force from the hinge on the beam. So we need to find out in this case value of Fh. So Fh in this case will be equal to 8 newtons. And so this is value of hinge force. So our final answer we can write down is 810 newtons. It's better to use 2 SF because in the raw data we have 2 SF. So this is our final answer. And this question has only 1 mark, and that is the answer mark. If you have got the right answer, you will get 1. For our party, it is given to us the block is now moved closer to end A of the beam. Mean this block is moved to the left. So we can simply imagine the block is somewhere here. So the 12 Newton force is acting at this point. So we can draw this is 12 Newton force. And it is also given to us that assume that the beam remains horizontal. If beam remains horizontal, it means that this angle also remains the same. So angle is still 50 degrees. So this is what we can conclude from remains in equilibrium. So angle also remains the same. State whether this change will increase, decrease, or have no effect on the horizontal component of the force exerted on the beam by the hinge. So we need to consider horizontal forces acting on the beam. So we have one horizontal force, that is component of tension, that is acting to the right. So it means that there is a component of hinge force that is acting to the left. And these two components, they have to be equal in magnitude. So let me draw this arrow again so you can compare the length of these two arrows. So the length of these two arrows have to be the same because beam is in equilibrium. So along horizontal there is no net force. So these two arrows are equal in length, mean they have the same magnitude. Now the question is that how we can figure out what is the effect on horizontal component of the force exerted by the beam, exerted by the hinge on the beam. So how we can figure out that the effect on horizontal component. To figure out that one, we can take moment about point A. So we will start taking moment about point A and then we will try to figure out the effect on horizontal component. So we will take moment about this point. Now if we take moment about this point, we have already discussed that vertical component of tension is producing counterclockwise moment. So in this case, we have this vertical component, this will produce counterclockwise moment, and this weight, this will produce clockwise moment, and this block will also produce clockwise moment. And if this beam is in equilibrium, so the moment due to weight 12 newtons and vertical component has to be equal. So simply you can say in this case clockwise moment, this has to be equal to counterclockwise moment. Means sum of clockwise moments has to be equal to sum of counterclockwise moments about point A, because we have assumed this is over pivot. So moment due to weight. Weight we have calculated value of weight was 9.2 and we have to multiply with the distance from the pivot, and distance from the pivot in this case is 0.25 because beam is a uniform beam. So the weight of the beam is acting at the midpoint. Plus we need to add, in this case, plus means you need to add next clockwise moment. So we can just assume actually before, let's say it was 0.35, now we can assume any value smaller than 0.35. So we can say in this case we have this is 12 multiplied by, you can take any value. So let's say in this case we take 0.30, just assume, you can take anywhere, even without value we can do this one. So I will explain you how we can do without calculations. And this one has to be equal to the vertical component of the tension, that is equal to 17 sine of 50 degrees. We will just write down this, no need to write down 13, multiplied by its distance from the pivot, that is equal to 0.50. Now in this case simply we need to compare, we don't need to calculate. So in this case you can see as this part decrease, it means this side also has to decrease. But you can see here this one remains same, the angle in this case also remain same. So it means that the 17, it should not be 17. The tension should not be equal to 17. So the tension in this case has to be smaller than 17. So it has to be lower than 17 newtons now. So the tension has to be lower than 17 newtons. So we can conclude from here. Because this side, the total moment decrease means the clockwise moment decrease. So the counterclockwise moment also has to decrease. That the distance of the vertical component of tension from the pivot remains same, angle remains same. It means tension itself has to decrease. A better way in this case, you can also write down T here. So you can say T has to decrease. You can write down 17, you can replace with T. So we have to say T has to decrease. If T decrease, how about effect on the horizontal component of tension? So we can say TH. TH has to be equal to T sine of 50 degrees. Now in this case, angle is the same, but T has decreased. So how about TH? So it means that TH, we can say the new value of TH. This one has to be lower than the original value of TH. So simply you can say TH in this case has been decreased. So this is how you can compare. So what is the effect on horizontal component of the force from the hinge on the beam? As horizontal component of tension has been decreased, it means as this component decreases, this component, horizontal component of the force from the hinge on the beam also decreases. So for answer of this question, simply you need to write down decreases. If you write down decreases, you will get in this case 1 mark, and that one is the B mark, decreases. So I hope this point is clear to you. If still you have any questions about this one, if this is not clear to you, just leave your questions in comments and I'll be answering as soon as possible. So let me explain you a little bit in a different way. I can even replace this 17 with value of T. So I can simply replace this one. So maybe this will make more sense to you. I can just write down here T. So if this decrease, how about the T? T has to decrease because angle is the same and the distance from the pivot is the same. So as T decreases, so we can write down T has to decrease. As T decreases, it means that the horizontal component has to decrease. As horizontal component of tension decreases, horizontal component of the force from the hinge on the beam also has to decrease because beam still in equilibrium. I hope this is clear to you. For question number 4, it is given to us two blocks slide directly towards each other along a frictionless horizontal surface as shown in figure 4.1. So these two blocks, they are sliding towards each other and the surface is frictionless as shown in figure 4.1. The blocks collide and then move as shown in figure 4.2. So we can see in figure 4.2, block X start moving backwards to the left and block Y continue moving to the left, and the momentums are given to us. It is given to us block X initially moves to the right with a momentum of this one, block Y initially moves to the left with this momentum. After the blocks collide, block X moves to the left back along its original path with a momentum of this. So this is momentum of block X. Block Y also moves to the left after the collision. For part A, we need to calculate block X as an initial kinetic energy of this, and we need to calculate mass of block X. So the first thing we need to understand in this case is we are talking about initial kinetic energy. Initial kinetic energy. So we have to take initial momentum, and this is initial momentum of block X. So we will take this is initial momentum of block X. We have kinetic energy. So you need to understand the way how to approach the problem. We have momentum of the block, we have kinetic energy of the block, and we need to calculate in this case mass. So we can start writing kinetic energy. Formula for kinetic energy we have, this is 1/2 mv square, and for the momentum E is equal to mv. Now somehow we need to connect these two together so we can figure out value of mass. So if we get kinetic energy formula, Kinetic energy, we can say this is 1/2 mv, and we can multiply this one with v. So we got here, this is 1/2 mv is equal to momentum, so means mv, and we have v. But v from here we can also get, v will be equal to p divided by m. So we have one p here and another p you can get from here, because we don't have the value of speed, so we have to convert this one in terms of momentum. So we can write down speed in terms of momentum. So this v we can write down, this is equal to p over m. Now you can see we have only three variables. Do we have the last one we can calculate, means mass we can calculate in this case. If we simplify this one, we can say this will be equal to p square divided by 2m. And for this question, we need to calculate mass. So we can rewrite once again, kinetic energy, this is equal to p square divided by 2m. And from here, we can write down mass. Mass will be equal to p square divided by 2 times of kinetic energy. So now just you need to plug in values. Value of momentum we have, that is equal to 0.37 square divided by 2 times kinetic energy, that is 0.30. So now if we simplify, we can find the value of mass. So the mass in this case will be equal to 0.23 kgs. So this is our final answer. A beautiful way to answer this question. And also you need to understand how we approach this problem. Means kinetic energy was given to us, momentum was given to us, and question was asking us to calculate mass. So how we can calculate? So you need to understand how to connect kinetic energy and momentum together, so you can find out value of mass. So that's the reason we rearrange this equation. So we try to write down this one in form of momentum, mass, and kinetic energy, so we can calculate value of mass. So this is how we have calculated value of mass. A beautiful way. Physics problem solving skills are very important. Not to always take the formula, plug in numbers. Take the formula, plug in numbers. Don't think about physics like that. Try to understand the situation. Try to connect things together. This is what questions are asking you. How you will connect these variables together. That's all. Data is given to you. Simply you need to understand how to connect them. Those connections you need to find out. I hope this question is clear to you. So the final answer is this. Final answer we have to write down up to 2 SF, because the raw data we have that has 2 SF. Mean the least number of SF in the given data is 2 SF. So we have to use 2 SF in the final answer. You can use 2 or you can use 1 more. So this is the answer. So this question has 3 marks. So you will get 3 marks if you have written this one. For writing this, you will get 1 C mark, and for writing equation for the momentum, you will get an other C mark. And the final mark is for the right answer. If you got the right answer, you will get 3 marks. So steps are very important. Always show your working so you can get the C marks. For part B, we need to determine the magnitude of the momentum of block Y after the collision. And this question is simply based on conservation of momentum. Because we have momentum before collision, if we calculate momentum after collision, momentum before and after has to be the same, because in this case there is no net external force acting on the system. So simply you can use conservation of momentum in this case. Momentum before has to be equal to momentum after. But we have to be very clear that momentum is a vector quantity. So we have to take one direction as positive. So in this case, we will take to the right is positive. If we take to the right is positive, this one will be positive. This one will be negative. This one also will be negative. And this is also to the right. We can say this momentum, let's say P, even you can say this is P, Y, and this one also has to be negative because this is to the left. Now simply we can add them together. So we have 0.3 0.37, we have plus, minus we have 0.65. This one has to be equal to minus 0.13, plus we have minus, this is p. So if we simplify, we can write down 0.37 minus 0.65. This has to be equal to minus 0.13. Minus sign is very important, minus p. So we have to find out in this case value of p. So if we solve this one for value of p, we will also get negative answer. That one will be equal to 0.15 kgs meters per second. This answer will be negative, means this momentum is negative because this is to the left and we have taken to the right positive. This question is simply asking you for the magnitude, so you can write down 0.15, and this question has only one mark, answer mark. If you have got the right answer, you will get this mark. For part C, it is given to us block X exerts an average force of 7.7 newtons on block Y during the collision. Calculate the time that the blocks are in contact with each other. It's a beautiful question and also straightforward question. Why it is beautiful is because question is asking you to calculate how much time they will spend with each other when they exert force on each other. By simply knowing the force and the momentum change, we can find out how long they will spend together. It's a beautiful way. You can calculate time. So you need to visualize, little bit imagine the beauty of physics. So you can appreciate the beauty of physics, not just plug in numbers and calculate answers. Okay, so let's try to answer this question now. I hope you got some idea how beautiful physics is to explain the beauty of nature. So let's try to answer this question. In this question, it is given to us force block X exerts this much force on block Y. So simply, first of all, we can draw here. So we have block X and we have block Y. So in this case, it is given to us block X exerts a force on block Y. So this is the force by X on Y, and Y will also exert an equal force in magnitude but in opposite direction on block X. So it means force on X is equal in magnitude to force on Y, but they have opposite directions. So we can take any one of them. We can take block X or we can take block Y and we can calculate time. So in this case, I'll be taking block X. So I will be looking at this block. So the net force exerted on the block means F net. This is equal to delta P over delta T. So the force exerted is given to us, that is equal to 7.7 newtons. And in this case, we need to calculate the change in momentum. So for block X, the change in momentum. So you see this direction is to the right and this one is to the left. So we have to take one direction as positive. So we will take in this case to the right is positive. To the right is positive. If we take to the right is positive, that also that will work. But I will take in this case to the left is positive. I'll be taking to the left is positive. Why I'm taking to the left is positive? Because the force on the block X is to the left. When it will collide, so this one is block X, this is block Y. So when block will collide with each other, this is block X, this one is block X. So when it will collide with block Y will apply force on X in the opposite direction. So the force on X will be to the left. So that's the reason I'm taking to the left is positive. So the final answer also will be positive. And so this force is positive. We are taking to the left is positive. So the force is positive. So we need to calculate change in momentum. So in this case, this is our final momentum. So we can say P final minus P initial over delta T. So a little bit in detail so you can get better idea. So we have P final, that is positive 0.13, and we have minus, and this momentum is negative because this is to the right, divided by delta T. So simply we can say this is 0.13 plus 0. This is also negative. So negative, positive, divided by delta T. Now if we solve this one for delta T, and so we can get the value of T. I'll be writing here now. So delta t in this case will be equal to 0.13 plus 0.37 divided by 7.7. So we can find out the value of delta t. Delta t in this case will be equal to 0.065 seconds. So this is our final answer up to 2SF, because in the raw data we have 2SF. This has 2SF, this also has 2SF, this also has 2SF. So the least number of SF in raw data equal to 2SF. So the final answer should have 2SF as well. So this is our final answer. And this question has 2 marks. The 1 mark you will get if you have written this step. If you have written this step, you will get 1 C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks for this question. And this is end of this video. And I hope these questions are clear to you. If these questions make sense to you, and if you find this video helpful, please like and subscribe, because your encouragement is very important, so I can make more videos for you. See you next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on waves and electricity from March 2023, paper 2, variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. For question number 5, part A, we need to find out time-based setting in seconds per centimeter of the CRO. Time-based setting simply is equal to time-based setting. Time-based setting. This is equal to total time divided by length of the wave. So we can say time in seconds divided by length of the wave in centimeters. Now, if you look at this given wave, in this case, you can see we have 1 complete wave. So this is 1 complete wave. And also we have half wave. So in this case, we have 1.5 waves. 1.5 waves. So in this case, total time will be equal to 1.5 times time period of the wave divided by length. In this case, if we look at given scale, we have this is 1 centimeter. Here we have 2 centimeters. And we have 3 centimeters, we have 4 centimeters, and here we have 5 centimeters, and we have 6 centimeters. So simply we need to divide this one by 6. This time is in seconds, and this is in centimeters. Now we need to find out time period. Frequency is given to us. So we can say time period will be equal to 1 over frequency. And frequency is 1 over 5,000. So we have 1 over 5,000. If we solve this one, in this case, we will get answer 2.0 times 10 to minus 4 seconds. So this is value of time period. Now simply we need to plug in here. So we have 1.5 and value of time period is 2.0 times 10 to minus 4 seconds divided by length of the wave, that is 6 centimeters. Now if we solve, we can get the final answer. Final answer will be equal to 5.0 times 10 to minus 5 seconds per centimeters. So our answer is 5.0 times 10 to minus 5 seconds per centimeter. So this is our final answer. For the second part, it is given to us the intensity of the sound detected by the microphone is now increased from its initial value of I to a new value of 3I. The frequency of the sound is unchanged. Assume that amplitude of the trace on the CRO screen is proportional to the amplitude of the sound wave. On figure 5.1, we need to sketch a new trace shown on the screen of the CRO. So in this case, intensity has been increased. Intensity has been increased from I to 3I. So this is we can write down. Now simply we need to find out how A has been changed from A to some new value of amplitude. But we understand intensity over amplitude square, this is constant, means the ratio between I and A square, this remains constant. So this is A nu square. We have value of A initial, that is equal to 1 centimeter. So this is 1 centimeter. So simply we can write on here, this is 1 centimeter square. So we have 3I, this is divided by A nu square. So we can cancel this I with this I. So we got A nu. This one will be equal to root of 3 times 1 centimeter. 1 centimeter. 1 centimeter. So this is value of A nu. So simply we can say from here, A nu, this is equal to 1 point. Now simply we have to consider new value of amplitude and we can sketch new trace. So the amplitude of new trace is equal to 1.73 centimeters and we need to use this amplitude and we can sketch the new trace. 1.73, so 1.2, 1.4, 1.6, so here will be 1.7. 1.2, 1.4, 1.6, 1.7. So here 1.2, 1.4, 1.6, so 1.7. Now simply we need to connect these points. So this is how you can sketch the curve. So little bit better we can draw this one. We can draw a little bit better this part. So we can simply connect from here. So this is how you need to draw the new trace. And amplitude of new trace has to be equal to 1.73 centimeters. For part B, it is given to us an arrangement for demonstrating interference pattern using light is shown in figure 5.2. And for part B1, we need to explain why a bright fringe is produced by the waves meeting at point P. So at this point, why a bright fringe is produced. A bright fringe at this point is produced due to constructive interference between two waves reaching at this point. So simply if you look at these two waves reaching at this point, these two waves will be in phase. So in this case, we have two waves here. These two waves are in phase. When they will meet, they will produce a super crest due to constructive interference because they have phase difference equal to 0. So simply you have to say in this case, phase difference is equal to 0. So there is constructive interference and a bright fringe is formed at point P. So for the answer of this question, simply you can say phase difference between waves at P is 0. So constructive interference and a bright fringe is produced at this point. You can also say this one in terms of path difference. Path difference, you can also say path difference in this case is also equal to 0. So that's the reason there is a bright fringe. For the second part, we need to calculate the distance capital D, means the distance between the slits and the screen. And this is about Young's double slit. For Young's double slit, you need to understand that AX is equal to lambda times D. And we need to find out D in this case. So D will be equal to AX divided by lambda. And value of A is given to us. This is slit separation. So simply we can write down this is 3.6 times 10 to minus 4. And also we have fringe separation is given to us. Fringe spacing. X is fringe spacing. Value of fringe spacing is also given. In the distance between two consecutive bright fringes. That is equal to 4.0 times 10 to minus 3. And the value of lambda is given. So this is value of lambda. We have 630 nanometers, 10 to minus 9. Now if we solve this one, value of D will be equal to 2.3 meters. So this is what you need to calculate. So this is value of D. So it is a straightforward question if you understand Young's double slit equation. For part C on figure 5.3, we need to sketch a graph to show the variation of X with lambda. From lambda equal to 400 nanometers to lambda equal to 700 nanometers, numerical values of X are not required. So for this one, we need to understand that AX is equal to lambda times D for double slit. We are talking about double slit experiment. So from here we can say X is equal to lambda times capital D divided by A. Question is asking us to sketch a graph between X and lambda. So from here we can see that X is directly proportional to lambda. So these two quantities, they are directly proportional to each other. So it means that we need to sketch a straight line. So simply we have to sketch a straight line. But this straight line should not start from 0, because at this point lambda is not equal to 0, so it cannot start from the 0. It has to be straight line because these two quantities, they are directly proportional, but it should not start from 0 because lambda is not equal to 0 at this point. If it was 0, lambda 0 x 0, then we can start from 0. So this is how you need to sketch. For question number 6, part A, we need to define potential difference across a component. And PD across a component, potential difference across a component, simply is equal to the amount of electrical energy converted into other forms of energy per unit charge. Electric energy into other forms of energy, other forms of energy per unit charge, amount of energy per unit charge. So this is how you can define potential difference across a component. Amount of electric energy converted into other forms of energy per unit charge. So this is how we define potential difference across a component. Let me show you the answer, how you can write down the answer. So this is how simply you can write down the answer. You can say energy transferred from electrical to other forms per unit charge. If you write on this one, you will get 1 mark, and this is B mark. For part B, it is given to us the variation with potential difference V of the current in a semiconductor diode is shown in figure 6.1. Use figure 6.1 to describe qualitatively the resistance of the diode in the range from V is equal to 0 to V is equal to 0.25 volts. 0 to 0.25 means until this point, 0.25. So in this case, current is equal to 0. So simply we can say resistance is equal to V divided by I. As value of V is 0.25 volts and current is equal to 0. So it simply means that resistance in this range is infinite. So simply we can say resistance is infinite. Resistance is infinite. For the second part, the variation, if any, in the resistance of the diode as V changes from V is equal to 0.75 volts to V is equal to 1.0 volts. So in this case, we have first of all 0.75. This will be located here, 0.75. So we can say this is 0.75. Now in this case, we can simply compare. We can draw one line from here. So we can draw the line here. So this is the line. We can draw the line here. And also we can see in this case the increase. So we can see the increase here. So simply we can see the increase here. So in this case, if you look at the increment, this increases by 2 small square. So we have one small square and other small square. We can also compare this one with the final value here. So we can draw the line here, and also we can draw this dotted line here, and we can see this change. So in this case, this is increases by from here. So we have one small square, we have two small square, we have three small square, and we have 4. So in this case, R is equal to V divided by I. So for the same increase in V, as I is increasing more, it means the resistance is decreasing between 0.75 and 1.0. So simply we can say R decreases as V increases. As V increases. So just 1 mark. If you write on this one, you will get 1 mark. 1 mark for this one. So this will be B mark. And this is also B mark. Means current is increasing more for the same change in V. So it means resistance is increasing. For part C, it is given to us the fixed resistor has a resistance of 5 ohms. Current in the battery is 2.7 amps. Then current in the fixed resistor is 1.5 amps. Calculate the current in the resistance wire. So this one is the resistance wire. So this is our resistance wire. Question is asking us to calculate value of current in resistance wire. So simply we can say, let's say current in resistance wire is equal to I1. And current in this fixed resistor, this current is I2. And we can also assume current coming from the battery Let's say that one is equal to I now. So at this junction, if we simply look at this junction, so we can simply say in this case I naught has to be equal to I1 plus I2. I naught is equal to 2.7. I1 we need to find out, and I2 is 1.5. So I1 from here simply will be equal to 1.2 amps. So this is how simply we can figure out. So the value of I1 is equal to 1.2. For the second part, we need to determine the resistance of variable resistor. So the best way to answer this question is simply we can connect a voltmeter across these two resistors. So this is our voltmeter, and this is connected across these two resistors. And the reading of this voltmeter has to be equal to the EMF of power supply, because power supply has no internal resistance. So this one has to be equal to 12 volts. So we can say in this case the PD across these two resistors has to be equal to PD across fixed resistor plus PD across variable resistor, and current in these two resistors is the same because they're connected in series. So simply we have to multiply this one by capital R. Now if we solve this one for capital R, our final answer will be equal to 3.0 ohms. So this is what we need to calculate for this question. So simply our answer is 3.0. Very straightforward question. For the third part, it is given to us wire XY has a length of 2.0 meters. Point Z on the wire is a distance of 1.6 meters from point X. The fixed resistor is connected to the variable resistor at point W. We need to find the potential difference between points W and C. A conceptual question, a beautiful question to understand and to improve your conceptual understanding of electricity. The question is simply asking us to find the potential difference between these 2 points. It simply means if you connect your voltmeter between these 2 points, the question is asking you what is the reading on this voltmeter. And reading on this voltmeter, we can simply find out if we have the value of potential at point W and we have value of potential at point C. To find value of potential at point W, we can simply connect a voltmeter across this variable resistor. If we connect a voltmeter across this variable resistor, we can find out value of potential difference across this one, because we have value of current that is equal to 1.5 amps, and the resistance of this resistor we have just calculated, that was equal to 3.0 ohms. So we can find out the reading on this voltmeter, that will be equal to 1.5 times 3.0. So we will get 4.5 volts, and in this case this side is at 0 volt, so this side will be at 4.5 because the potential difference between these two is equal to 4.5. So simply we can say this is value of VW. So we can write on here we have potential at point W that is equal to 4.5 volts. Now we need to find out the potential at this point. So we can also connect a voltmeter between Z and between Y. So we have to find the reading on this point. In order to find reading on this voltmeter, first of all, we need to understand resistance. R is equal to rho L by A. For uniform wire, for uniform wire, very important point for potentiometer. For uniform wire, R is directly proportional to L, the length of the wire, because resistivity of same wire is constant, and if cross-sectional area is also constant, then resistance is simply directly proportional to L. So we will be using this principle and we will try to find out reading on this voltmeter. So in this case, simply we can say, as this is the same wire, so current in this wire is the same. So we can say current WY. We are taking the whole wire. That current is equal to current passing through CY. So we can say CY. Current is equal to the potential difference across this wire. So we can say PD is WY divided by LWZ. So this one is LWY. Yes, we are talking about whole wire, LWY. So we have IZY, so the potential difference across ZY divided by the length of ZY. zy part of the wire. Potential difference we have in this case across this total wire, that is equal to 12. So we can say this is equal to 12. And the length of the wire xy we have, that is equal to 2.0 meters. So vzy we need to find out. And the length of this part we have, that is equal to 2 minus 1.6. So we have, this is 0.4. So we have simply 0.4 because point Z on the wire is a distance of 1.6 from point X. Mean this distance is equal to 1.6 meters. So this distance will be 0.4 meters. From here we can find out value of ZY. Then this one will be equal to 12 multiplied by 0.4 divided by 2.0. So if we solve this one, we can find out the value of potential across this part of the wire. So in this case, we can simply cancel this 2 with this. So we will get 6. And now simply we need to multiply 6 with 0.4. So if we multiply 6 with 0.4, we will get, this will be 2.4 volts. So this is 24 2.4 volts. So we have value of ZY, potential difference between Z and Y. So in this case, this side is also at 0 potential. So this side has to be at 2.4 volts. And now we need to find the difference between these two. So we can say the difference between point Z and W. This will be equal to the potential at point W minus the potential at point Z. Potential at W we have that is equal to 4.5 and potential at Z we have that is equal to 2.4. So we will get final answer in this case 2.1 volts. So this is the potential difference between point W and point C. So the answer is 2.1 volts. So this is how you can figure out a beautiful question. You need to understand how to answer in a systematic way so you can improve your understanding of this. I hope this one is clear to you. If you have any questions about this one, you can leave your questions in comments. For part 4, it is given to us the resistance of the variable resistor is now increased. By considering the currents in every part of the circuit, state and explain whether the total power produced by the battery decreases, increases, or stays the same. So total power produced by the battery. So power of the battery. So we can start from this one. Power of the battery is equal to I total in the circuit times EMF of the power supply. So we can say EMF of the power supply. So this is power of the battery. EMF of the battery stays same. Now simply we need to look at total current in the circuit. If we increase the resistance of this variable resistor, so it means that current in this branch has to decrease because the PD of this branch remains the same. So if we connect voltmeter here, PD remains constant, but resistance of this branch has increased. It means current in this branch has to go down. So current will be lower than 1.5 amps. So current has to decrease here. But PD across this wire remains the same. And the resistance of this wire also remains the same. Resistance also remains the same. So it means current in this part of the wire also remains same. So it simply means that total current coming from the battery, this one has to decrease because current in this branch has been decreased. So total current coming from the battery has been decreased. So it means that the power of the battery, this will decrease. Means battery will deliver less energy per second. So the power of the battery decreases because EMF of the battery remains same. So the main point is here. The resistance of this branch increase, PD remains same because this is connected with the power supply. EMF of the power supply is constant. So current in this branch will decrease. As current in this branch decrease, but current in this wire remains same. So it means the total current will decrease. So this is the total current, I0. We can say this is I1. This current we can say this is I2. So we can also write down, in this case, I0 is equal to I1 plus I2. But I2 in this case decreases. This remains same. So it means I from the battery decreases. But EMF of the battery is constant. So it means the power of the battery will decrease in this case. So let me show you the answer, how you can write down your answer. So this is how you can write down your answer. In your answer, you can mention these points. You can say current in fixed resistor decreases. Current in resistance wire is unchanged. So current in battery decreases. Means the total current coming from the battery decreases. That EMF of the battery is constant. So power of the battery decreases. A beautiful conceptual question. For our question number 7, part A, it is given to us nuclei X and Y are different isotopes of the same element. Nucleus X is unstable and emits a beta plus particle to form nucleus Z. By comparing the number of protons in each nucleus, we need to state and explain whether the charge of nucleus X is less than, is the same as, or greater than the charge of nucleus Y, nucleus Z. If you look at nucleus Y and nucleus X, they are isotopes of the same element. As they are the isotopes, it means they have the same number of protons. So they have the same protons, so they have the same charge. So pretty straightforward. So we can say they have the same charge. So we can write down our answer for Y. But if you look at Z, Z is formed when X emit beta plus particle. So this is formed by beta plus decay. Beta plus decay. And also in this case, there will be emission of electron neutrino. So let's say atomic number of this one is Z, mass number is A. So the mass number of this one will be the same, but atomic number will be Z minus 1. So it simply means that Z has one less proton. This has number of protons equal to Z, and this one has number of protons equal to Z minus 1. So Z is representing number of protons. So X in this case has more protons. So we will say in this case X has more protons. And so X has greater charge. X has more protons, so X will have greater charge. So if you have understanding of these points, we can write down our final answer. So this is how you can write down your final answer. In the answer, you can mention X has the same number of protons as Y. So the charge of X is the same as charge of Y. X has one more proton than Z, so X has greater charge than Z. So this is, you can see, this is also representing number of protons in Z. So number of protons in Z. So this has X, this one X has Z number of protons, Z has Z minus 1 number of protons. So this has more charge. For part B, it is given to us hadrons can be divided into two groups, P and Q. P is baryons. State the name of group Q. So simply in this case, you need to understand hadrons can be divided into two parts. One we call is mesons, and the second one we call is baryons. So the name of baryons is given, and so Q has to be mesons. So Q has to be mesons. And for the second part, describe in general terms the quark structure of hadrons that belong to group Q. Group Q is meson. Means what is the quark structure of mesons? Mesons simply they consist of one quark and one antiquark. So simply we can say mesons consist of one quark and one antiquark. General structure. It's asking you quark structure in general terms. So we can say antiquark. So that's all what you need to write down. So in general terms, we can say mesons consist of one quark and one antiquark. And the group of the name is mesons. And that's all for this paper. I hope you have better understanding of these concepts. If you have any questions from this paper or from any other paper, you can leave your questions in comments and I'll be answering as soon as possible. See you in next video. And if you like this video and if you found this video helpful, then please like and subscribe because your encouragement is very important.